Hello, mathematicians. So in your math book, go to page 357. And today you guys are going to be learning about sequences. And so what a sequence is it's an ordered list of numbers. So kind of like what you see right here. So that would be a sequence. And then in a sequence, each number is called a term. So here, like 1 is a term, 3 is a term, 5 is a term, and so on. And there's different types of sequences, but today we're going to be focusing on arithmetic sequences. And in an arithmetic sequence, each term is found by adding the same number to the previous term. Okay, so let's look at this graphic organizer. So here we have a sequence 1, 3, 5, 7. And so we need to continue that sequence. So you're essentially what you're doing is looking for a pattern. So you're looking for, if you're starting at 1 and get to 3, how do you get there? Well, it's getting bigger, so we know we're adding, and we're adding by 2. And so to get from 5 to 7, same thing, we're adding by 2. To get from 5 to 7, we're adding by 2. So to find the next number or the next term in that sequence, we would add 2 to it, and that would give us 9. Okay, so this would be finding the next term. And then so for that sequence, to describe it, what we're doing is we're adding 9 to the previous term. And then sequence below, we're starting at 1 and going to 1.5. So it's getting bigger, and it's getting bigger by 0.5. And then to go from 1.5 to 2, again, it's getting bigger by 0.5. So to find the next terms, we're just going to continue to add 0.5. So this would be 2.5, 3.0, or if you just write 3, that's fine, and then 3.5. So to describe that sequence, I just like to put plus 0.5, and then that tells me that we're adding 0.5. Okay, so that's what an arithmetic sequence is. It's a sequence of numbers, and then you're just continuing to add the same number. So go ahead and turn the page, and we will look at a couple more examples and then practice them together. So here in number 1, we need to describe the relationship, and in this sequence right here, and then write the next 3 terms. So you're looking, again, if you're starting at 8 and going to 13, how do you get there? Well, we know it's getting bigger, so I put a plus sign, and it's getting bigger by 5. And so when your question's asking to describe the relationship, that means it would look like this. You're just adding 5. Now, some of us that have trouble like looking at how do you get from 8 to 13, if it's hard for you to add up, then you can do your second. So this is our first term, and this is our second term. So you can do your second term minus your first term, and that difference is 5. So if it's hard for you to figure out how to add up, then you can subtract to find out what is that relationship. And then the second part of this is the next 3 terms. So you're just going to continue to add 5 from your last term. So that means that the next 3 terms would be these right here. Okay, let's go down to number 2. So same thing, describe the relationship. Here's the sequence, and then what are the next 3 terms? So sometimes we may have decimals, so it's still the same thing. So you're looking at how do you get from your first term to your second term. So in this sequence, the relationship would be adding 0.2. And then when you're finding the next 3 terms, you're just going to continue to add 0.2. and then this is what those next three terms would be. So when you guys are doing these, like submitting your answers, the relationship, to describe the relationship, like I said, I just put a 0 and then whatever you're adding, and then the next three terms would be this. And so this is what your final answer would look like. Okay, so let's practice some more. So same thing, you're describing the relationship and then writing the next three terms. So we're going to look at A. So at A, we're looking at, if we start at 0, how do we get to 13? Well, we know that it's getting bigger, so it's a plus sign, and it's getting bigger by 13. And that same pattern is going to continue. Okay, so since we don't really have that much room here, I'm going to write in the margin. So our relationship is plus 13, and then we need to continue the pattern, or continue the sequence by finding the next three terms. So we're going to just add 13 to 39. So that would give us 52. Then from there, we're adding 13. So that would be 65. And then our third term would be 78. Okay, next up, let's go to B. So we're looking, how do we get from 4 to 7? So it's getting bigger, so that's a plus, and it's getting bigger by 3. So plus 3 would be the relationship. And then to find the next three terms, we're going, looking at our last term in the sequence, and we're just going to be adding 3 to it. So that next term would be 16, and then we're going to add 3 more, which would be 19, and then 3 more, which would be 22. All right, let's look at C. So C, we know we're getting bigger, and we're getting bigger by 0.3. So again, if it's hard for you to add up, then subtract to find the difference, and then that's how you could figure out this relationship. So our relationship is 0.3, and then to find the next three terms, we're going to our last term and adding that 0.3 to it. So this would be 2.2, then 2.5, and 2.8. And remember that when you're adding, so let me show you. Our last term was 0.9, and we're adding 0.3, not 0.9, 1.9, 1.9 and 0.3. When you're adding decimals, remember you have to line them up. So 9 and 3 is 12, carry the 1, and then that's how we get 2.2. Okay, next up, let's go to D. So on D, our first term is 2.5, and our next term is 3.0. So that relationship is, we're adding 0.5. And then to find the next three terms, we go to that last number of 4.0, and we're adding that 0.5. So for D over in the margin, my relationship is adding 0.5. So again, I just put a plus. And then my next three terms would be 4.5, 5.0, or if you just write 5, that's fine, and then 5.5. All right. Go ahead and turn the page. So another part to this lesson is writing an algebraic expression. Okay, and an algebraic expression is going to have a number, a variable, so remember variable is a letter, and then an operation. And when we say operation, that means like add, subtract, multiply, or divide. So those are the components of an algebraic expression. And so another thing that you have to be able to do is write an algebraic expression from a sequence. So in this problem here, they're giving us a table. So this right here is the sequence. So it's 2, 4, 6, and 8. Okay, so when we're looking for that relationship, you're still looking at how do you get from your first term to your second term. Well, this relationship is constantly adding 2, right? So that's an arithmetic sequence. But this is asking us to write an algebraic expression, so I can't just write plus 2. So when it's asking you to write an algebraic expression, one thing that I want you to look for is what would the previous term be? So we know if we're starting at 2 and we go to the right, then we're constantly adding 2. But what if we were to go back a number? What would that number be? Well, that number would be 0. So when that's true, then when you're writing your algebraic expression, then this number, that is your relationship. That'll be your number. And then you'll see that we use n as our variable here. So 2n would be our algebraic expression. So what that means is that whenever you want to find the value of a term, then you can just plug in that term. So for example, here, 2 is in, and this kind of shows us right here, 2 is in the first position. So let me write this right here. So to check if this expression is correct, all I need to do is substitute the number 1 because this is in the first position, and 2 times 1 is 2, so that checks out. And then 4 is in our second position. So 2 times 2 is 4, and yeah, that checks out there. And then 6 is in our third position. So 2 times 3 is 6. So yeah, that works. So that confirms that 2n would be our algebraic expression. Let's go down to number 3. So in number 3, they give us a table. So, and it's telling us that, I'm just going to abbreviate for you. The first week, the store sold 5 boxes. Each week, the store sells 5 more boxes. So our sequence would look like 5, 10, 15, and so on. And we want to know what algebraic expression could be used to find the total number of boxes at the 100th week. So this is where being able to write an algebraic expression is helpful, because we wouldn't want to write this sequence out to 100 terms. That's a lot of work, okay? But if we're able to find the expression, then we can do that faster. So here's my sequence to get from 5 to 10. We know that we add 5. Go back 1. So if we went back 1, then that number would be 0. So that means that my expression is just going to be 5 times n. So this would be our algebraic expression. And then it's asking, we want to find at the 100th week. So this would be 5 times 100, because 100 is our term that we're looking for. And then that means it would be 500. So at the end of 100 weeks, 500 boxes will have been sold. Okay, turn the page. So now we are on page 360. And let's look at E. So E is asking us if the pattern continues, what algebraic expression could be used to find the number of circles in any figure? How many circles will be in the 50th figure? So we're looking for an algebraic expression, and then how many circles in the 50th figure. So in this first figure, there's 3 circles. Our second figure has 6 circles, and our third figure has 9 circles. So that pattern is, or the relationship is, increasing by 3. Now, if we went to, if we had, let's say, figure 0, how many circles would be there? Well, there would be 0. So since the previous term would be 0, then our relationship is, or our algebraic expression is going to be 3n. This is our algebraic expression. And then to find the number of circles in the 50th figure, we're just going to multiply 3 times 50, and that would be 150. So the great thing about being able to write an algebraic expression is that we could just quickly be able to determine how many circles would be in the 50th figure without having to draw out all of those circles. That's a lot of work. Okay, let's do some guided practice questions together. So in numbers 1, 2, and 3, you're describing the relationship. So that means it's going to be plus and then whatever number it is. But please do know that sometimes the relationship might be a minus, like that sequence might be getting smaller. And then we have to write the next 3 terms. Okay, so go ahead and look at number 1. Okay, so for number 1, our relationship is adding 9. And then the next 3 terms, so after 27, we're adding 9. So the next 3 terms would be 36, 45, and then 54. Okay, go ahead and do number 2. So for number 2, our relationship would be that we are adding 5. And then so our next 3 terms would be 24, 29, and then 34. And then go to number 3. So for number 3, the relationship is that we're adding 0.1, or if you guys just write 0.1, that's fine. And then the next 3 terms would be 1.4, 1.5, and 1.6. All right, the last one we're going to do is number 4, and we will work on this one together because I know that the algebraic expressions are kind of confusing. So number 4 says that Hannah has a doll collection. The table shows the number of dolls in her collection for 3 years. So that's right here. Suppose this pattern continues. Write an algebraic expression to find the number of dolls in her collection after n years. And then how many dolls will Hannah have after 25 years? So this sequence would be 6, 12, 18. We know it's going to continue. If we were to go back a term, let's see what it would be. So this relationship we know is adding 6. So that means to go back a term, we're subtracting 6, and that would be 0. Okay, so then that means that when we write our algebraic expression, it's just going to be 6n. And then to find how many dolls after 25 years, all we need to do is substitute n with 25. And 6 times 25 is 150. So after 6 years, she would have 150 dolls. Okay, so a quick recap. When it's asking to describe the relationship, this is where you're just going to put plus and whatever that number is, or minus if it's getting smaller. And then for the next 3 terms, you're just going to continue that sequence. And then when it's asking for an algebraic expression, you're going to have a number, a variable, and an operation.